Hey, Ram, sorry, we did number 5 and then I forgot to record. So here is number 5. We're trying to find in radians how much a second hand of a clock will move in 2 minutes and 20 seconds. We said the second hand on a clock in 2 minutes will do 2 complete revolutions, which we said was 4 pi, is kind of like hidden back in here. 4 pi, because 1 revolution is 2 pi. So 4 pi, and then 20 seconds is a third of a rotation. So we took a third times 2 pi, and that's 2 pi over 3. So we did 4 pi plus 2 pi over 3, and we got 14 pi over 3. Or 4 and 2/3 pi. That would work as well. But then we also said that, like, okay, so 2 rotations would be 720 in degrees, right? And a third, or 20 seconds, a third of a revolution would be 120 degrees, which together would be 840. And then if you want to convert that to radians, if your brain thinks better in terms of degrees first, then you can convert to radians and you would get 14 pi over 3. So either way, whatever, that would work. Okay, all right, here we go. 12 revolutions per minute. That sounds like a unit multiplier thing, so let's go 12 revolutions per 1 minute. Okay?
How many revolutions are radians?
And I want radians per minute. So the bottom gets to stay minutes, but I have to go from revolutions to radians, okay? So I want which one to go on the bottom?
Revolution.
I want revolutions to go on the bottom, and I want radians to go on the top. So now I just have to figure out
This is 6.28.
what this is. Yeah, kind of, yeah. How many radians are in 1 revolution? 2 pi or 6.28, right? 2 pi radians in 1 revolution, and then we can
12 times
get rid of our revolutions,
pi.
and I'm just going to leave it. I'm just going to leave it as, if we take 12 times 2 pi, that'd be 24 pi radians per minute. Okay, or you could put it as a decimal, but 24 pi radians per minute. There you go. Okay, that's just like a conversion thing. Okay, good?
Angular and linear speed.
Angular speed and linear speed. All right.
Are these the ones that are like they're not bad. They're just
Because it's like caramel in the middle.
yeah. I thought it'd be like soft, but it's not.
Oh.
I like the ones that are like French toast.
Oh, I know you're talking about. Yeah, nasty.
Okay, so the next one, 7 and 8 are pretty similar to each other, and these seem like really hard problems, but they're really not too bad. Okay, but I'm going to draw a picture of what this looks like. So a bicycle has 25-inch wheels, but keep in mind that is in diameter. Okay, so 25-inch wheels would be a 12.5-inch radius, right? Okay, so that's what we've got going on here, which turns at 80 RPM. What does that mean? What does RPM stand for?
Revolution per minute.
80 rev per 1 minute. That's exactly what we just got done doing, right? Okay. We want to find, if that's going 80 revolutions per minute, how many radians per minute are being covered, because that's what the angular speed is, like what the angle is rotating at. So that's exactly what we just got done doing. Instead of revs per minute, I want radians per minute.
So 2 pi.
So I'm going to change from revolutions to radians, and 1 rev is 2 pi radians. Okay, so I'm going to cancel my revs off. And if you want to leave it in terms of pi, that's fine.
Okay. 160.
160 pi radians per minute. That is the angular speed. That's how fast the angle is rotating. I mean, that's a lot. 2 pi is one revolution, right? So if we're doing 80 revolutions, that would be 160 pi revolutions, or what, radians, whatever, right? Okay. Now here's the deal. I know that as, like, let's say I have a fleck of dirt on this bike, and that fleck of dirt is like rotating around. I know that that fleck of dirt is rotating at 160 pi radians per minute, right? But I want to know what that is in like terms of like feet and miles and stuff. Like, I don't want to know the angle. I want to like know actually like how fast is that bicycle traveling, right? In like feet per second or whatever, right? So what is the linear speed in inches per minute? I'm just doing another unit multiplier, and I'm starting with what I ended with right here, which is 160 pi radians per 1 minute, right? I'm just starting with this, okay? And instead of that, I want inches per minute, okay? I want inches per minute. So I have to change radians to inches, okay?
1 radian.
1 radian
12.5.
is a radius, right? And 1 radius length, they said over here, was 12.5 inches. Does that make sense? 1 radius is 12.5. So now I have, if I cross off my radians, right, I have it in terms of inches, but let's keep going because I want instead of, oh no, I do want per minute, right, not per second. Okay, so then we're good. So let's go ahead and let's multiply the pi through there. So it's 160 pi times 12.5 in inches per minute. Go ahead and fill that all as a decimal.
6,283 inches per minute.
6,283 inches per minute.
Yes.
Okay, and so we could figure that out in miles per hour and all the things, which is what they're gonna have you do down here. They want feet per minute, then they're gonna have you do miles per hour stuff, okay? All right, do you want, number 8 is the same as number 7. I will get you set up, and then do you wanna try them by yourself? Maybe? A circular paddle wheel of radius 3 feet, okay? So 3 feet is from here to here, 3 feet. Rotates at 12 RPM. That's what you're going to start with. 12 rev per 1 minute. They want you to convert to angular speed. What units are angular speed in?
Radians per minute.
Radians per minute. Okay, so convert him to radians per minute. See what that is. Then do part B, then do part C. I'll give you a second. Try and see if you can model number 8 after number 7. And see what we get.
The speed of the current would be linear.
Yes. Speed of the current is asking for linear speed, yeah. I don't know what that is. Pi, whatever that is.
What does it call something feet on a radian?
What?
It's the radius.
It's the radius of the wheel. Yep.
I didn't see that. What's 24 times 3 pi? 24 times 3 pi.
Oh. I think I did that right.
That's what I got.
That's not, I mean, that's not terribly fast. You left it in terms of pi, that's
I
fine.
left it at 72 pi.
Yeah, that's fine, that's fine. Okay. This is all, like all of that linear speed and angular speed is all unit multipliers. Or the, what does he call them? Railroad tracks?
Yeah.
Railroad tracks. The official term is unit multipliers, but whatever. We'll let Mr. Muth do whatever he wants.
Yep.
Mm-hmm.
It's kind of slow.
Okay, how are we feeling about that? Pretty good? Yeah?
Very sufficient.
Okay. All right, A and B are going to be like the same as each other, so we'll do A and then I'll see if you can do B. The length of an arc intercepted by a central angle. Okay, what is an arc? What are they talking about? Yeah, it's like the pizza crust. Like we want to know the crust on it, right? So if the radius is 10, I'm going to go here. Boop. Okay, the radius is 10, this is 10. Boop. Okay. How much-ish is 135 degrees?
Not quite.
Like, do you think about that?
It's like
135 is like 90 plus another 45. So like over here. Does that make sense?
it's always almost right.
So like halfway between 90 and 180. This is 135 degrees. I want to know what the length of this pizza crust is. The length of that arc, right?
So
Okay,
like
but
circumference.
so circumference is the whole thing around, right? So that's kind of what we're dealing with, the circumference. How do you find circumference?
2 pi r.
2 pi r. So if I were to find the whole circumference, I would take 2 times pi times 10. But I don't want the whole circumference. I only want this much of it, right?
135 divided by 360.
Which is 135 over 360. Okay? That's the fraction of the circle that I want, right? Okay, so maybe practice typing that in. 2 times pi times 10 times 135 divided by 360. 23.6 centimeters. All right, now hold on before we do the next one. Just wait a second. Let's guesstimate and see if that seems reasonable, right? One radius length is 10, right? How many degrees does it have to be before this length here is 10?
9.
What is 1 radian in terms of degrees? 1 radian is equal to how many degrees?
Oh, it's 57.
57, right? 57 degrees is 1 radius, right? So 135 is a little bit more than 2 units of 57, right? And this is a little bit more than 2 units of 10, right? Okay, okay. All right, you do part B. The next one, they have them actually drawn for you. That's kind of fancy.
What are they doing?
I don't know, that's what I'm trying to figure out.
Oh.
They have like gloves on or something.
Did you say you need to reset my calculator before the
Why is hers in
Probably.
fractions? How do you get it out of fractions only? It's only doing that.
How do you get it to do like a decimal number?
Yeah.
Hit the math button. And is it right there on the screen? Hit decimal.
But mine was on fractions and it was still working.
You want me to reset it right now? I don't know. What does that come out to be? Somebody have an answer?
Yeah,
can-
I
what'd you get?
got
What'd you get?
1.99 inches.
1.9. Oh, that's fancy. That is
Because it's 57
about,
degrees.
that's about 1 radian, right? 1.99 is about the same thing as the radius here because 57 degrees, right? It's actually 57.3 degrees, and that's the reason why it's not exactly 2. So, but that should kind of like make sense in your brain that like, oh, okay, that seems like an appropriate answer, right? Yeah. Okay. All right, now, instead of talking circumference, do we need to go back? No? Instead of talking circumference, we're talking area. But it's the same thing, right? How would I find the area of that entire circle? Pi r squared, right? Okay, and the radius here is 3. So if I was trying to find the entire area, it would be pi times 3 squared. But I don't want the whole area of this whole circle. I only want 120 out of 360, okay? Now, if you want to reduce and you recognize that that's 1/3, right? 120 over 360 would be 1/3. You could totally do that also, but it's not wrong if you just do 120 and 360, that's fine. So, pi times 9. Yeah, that type of thing, whatever.
9.42.
9.42, and that is in centimeters squared. Don't forget to square it because it's area, okay? All right, you do the next one.
very interesting for this next.
Interesting. It is very interesting. Did you not get something?
Oh, it's in a fraction.
Hey, let me reset your calculator quick.
If you want the decimal, she has to go in.
Yeah,
push
all you
the
have to do is
decimal
hit
button.
the math button, and you just go down to decimal and enter, and so it's saying, do you wanna take your answer and convert it to a decimal? Yes,
So I
we
have
do.
to do that every time.
Not anymore.
How do you even reset these things?
Go to second, the plus sign right above enter, where it says memory.
Oh.
Okay, and then you have to, I've reset both the all RAM and the defaults. I think it's for defaults, it's probably like causing it to do that. Okay, so now what do we just do? I'm gonna do 16 pi times 225 divided by 360, something like that, right? There you go. Somehow, somewhere, something got switched off, so it's only in fractions. Okay, good. What we got? We got lots more time, don't we? Do we have lots more time? I think maybe. Let's do some of the easy trig stuff. Holy moly, because we got 2 more full pages. What? Holy crap. Holy crap. Yeah. 11 and 12 the same? No, they're not. 11, use the right triangle below to find each of the 6 trig ratios of angle theta. So, what are the 6 trig ratios?
Sine, cosine.
Sine of theta equals cosine of theta equals, I'm using like the whole page. Tangent of theta equals, what goes with sine? Cosecant. She knew what I was going to ask. Secant of theta equals cotangent of theta equals. All right. Yeah, it has been a hot minute. Okay, before we start filling stuff out, right? Oh, if you want to write SOHCAHTOA, SOHCAHTOA. Beautiful. Okay.
Wait, before you ask that question.
Before you ask that question,
I'll tell you what it is.
this hypotenuse is a squared, b squared, c squared. A squared would be like 4 squared plus 7 squared equals c squared, so 16 plus 49, which is the square root of?
It's not a nice number. It's 8.06.
Oh,
You're gonna want
we want the square root. So we want the square root of 65?
square root of 65. Yes.
Square root of 65. We'll leave it as a square root of 65.
Because we'll have to rationalize.
Yep, because we'll have to rationalize. Okay, so let's label our sides too also. Which side is the opposite side? 7. Hypotenuse is the square root of 65, and the adjacent side is 4. Okay, so sine is OH. What's he look like?
7 square root of 65.
It'd be 7 over the square root of 65 when we rationalize.
65 over
Yep, 7 square root of 65 over 65. Can you guys do that in your head? Yeah, the rationalized part. Okay. Cosine is A over H, so 4 over the square root of 65, or
4 square roots of 65 over 65.
4 square roots of 65 over 65. Tangent is OA. That's nice. 7 over 4. Perfect.
Which means cotangent is
4
4 sevenths.
sevenths. Yep. I'm going right the same way you are. Okay, sine was 7 over 6 square root of 65, and so cosecant, if I flip that one,
Is square root of 65 over 7.
square root of 65 over 7. Secant will be
Square root of 65 over 4.
square root of 65 over 4. Perfect. Okay, and that's what they want for those guys.
Easy peasy.
Yep, those are ratios. When it says find the trig ratios, that means find the fractions. That's what these are. Right? Okay? Now, number 12 is easier than that because we only have to use one trig function. It says find the length of side H. Okay, so this guy's side H, but then they give you the things. Given that angle A is 50 degrees, okay, and the distance from C to A is 20. Okay, so I'm going to label that guy on there.
Call H X because if you,
We can if you want to.
because if
Yeah.
you call it H, you're going to
it's the
get
same thing.
Yeah, right. So yeah, let's change it to X. I like that idea. Okay, which one?
It's just like 20 centimeters, so it has a unit.
Oh, sure. I like it.
Yeah, it's confusing.
That'll work. Okay, 20, yeah, I know, because then I'm like, oh, is that 20 degrees? Did I label it wrong? Whatever. Okay, 20 centimeters. Okay, so now we have to choose which trig function we're going to use. So 50 is what I have here. Opposite is x, and this guy's adjacent, right? So tangent, and we do tangent of what? What goes inside the tangent?
50.
50. Okay, which means our calculator needs to be in degrees, because 50 is a degree measure, all right? Equals, tangent is opposite over adjacent. So does the x go on top or bottom? Top. Over 20, and then to get rid of the 20, I move the 20 to the other side.
23 points.
So 20 times tangent of 50, and x is 20 what?
23.8.
23.8 centimeters. Okay, now,
Which would make sense.
because this angle would be how much?
40.
No.
I'm just thinking of
These two have to add up to be
50, 90.
90, right?
So it's going to be
40, right? And so this side, 20, should be smaller than this side, right? Okay, so 23.8.
Yep.
That sounds good. Okay, that one wasn't too bad. You only have to use one trig function there. But you still have to set up your ratios just like you did over here, right? Like x over 20, okay? Holy moly, holy moly, holy moly.
Can we go after these two?
Let's do these two and then we'll be done.
Oh, shucks.
But this one says solve the triangle. So we need all the things. So we need capital A, we need capital B, we need capital C, we need lowercase a, lowercase b, lowercase c. This is the icky part. That's not too bad. It's not too bad, okay? We know that C, this angle right here is 30, okay? So lowercase c is 30. But that means, oh, and lowercase b, or not lowercase c. Capital C is 30, capital B is 90, capital A is
50. Wait, no, not 50. 60.
60. Yeah, so we can figure that stuff out because these have to add up to be 180, right? Lowercase a is 10. All right, so do you want to find B or C first?
C.
Okay, I'm going to label him here. C? We want to be weird? Okay, that's fine. 30 here. If we're solving for C first, C is the which side?
Opposite.
Opposite, and the only side that I know is 10, so I have to use 10, and that is the
Tangent. Well, that's it.
adjacent side. So we're going to use TOA, which is tangent. Tangent of what?
30.
30 equals opposite, and the opposite is
C.
C over 10. And so to get C by itself, we're going to multiply by 10. So 10 times tangent of 30, make sure your calculator's in degrees.
5.77.
5.77. Cool. Now, we could do another trig function if we want to, and then that would be pretty easy, right? You'd rather do a trig function? Yeah. Or you could do the Pythagorean theorem with these guys, but 5.77 is kind of ugly. So let's do another trig function. Let's do 30 degrees. We need 10, which is the adjacent side, but B now is the hypotenuse side, which, so we need hypotenuse and adjacent, or excuse me, yeah, hypotenuse and adjacent, which is cosine of 30 equals A over H. Ooh. A is 10 and H is B, right? How do I solve for B when B is on the bottom?
10 divided by cosine.
Yeah, we switch these two guys, right? So B is equal to 10 divided by cosine of 30. Do we remember doing that?
11.5.
Which is 11.5, you say?
Yes.
Okay, real quick before we move on. The biggest angle is the opposite the biggest side. The smallest angle is the opposite the smallest side. Looks good. Okay, happy with that? All right, 14. I got to erase all my stuff up here because we got to use the same triangle for this guy. All right, capital A, capital B, capital C. Lowercase a, lowercase b, lowercase c. Okay, we know that lowercase a is 3 and lowercase c is 7. And we know that capital B is 90. All right, okay. Do you want to use the Pythagorean theorem to find B? Since they're 3 and 7? Should we do that? A squared plus B squared equals C squared, right? So 9 plus B squared equals 49. And if I subtract the 9 over, B squared is 40, and the square root of 40 is something. Like 6 point, I don't know.
Can we leave it as square root of 40, or do you want to put it as a
Let's
decimal?
not. I think we should, since we didn't for the other side. Well, actually, I don't know.
I did not do this right.
What?
I did not do that right.
Yeah, you did.
No, I did not.
What?
No, I did not.
3 squared?
Which side is side C? Which side is side C? Side C is actually B, little b. Because I'm looking at this and I'm like, the square root of 40 is
Well,
6
that
point
was-
something,
that was
right?
their
That was
fault
dumb,
because
yeah.
that was stupid.
The square root of 40 is 6 point something, and I'm like, that can't be right, because 90 degrees is my biggest angle, and that's got to be the biggest side. That's not going to work. So,
it's the square root of 3.
so this should be 49 right here, or like 7 squared right here.
It should be
49.
7.62.
And C should be over here, which is actually B. Okay, so B squared. So 9 plus 49 is 58. So 58 is B squared. That was tricky.
It's 7.6.
7.62. Perfect. That's better.
Yeah.
Yep.
So now we're gonna have to use a trig function.
Yeah. So do you want to solve A or B first?
And
This is 3. This is 7. And this is 7.62. Okay. We're going to solve A first. All right, here we go. So A. All right. I have to use a trig function. Which two sides do you want to use? We have all three of them.
tangent because
We want to use this side and this side, which is opposite and adjacent, right? So we're going to use tangent. Okay, now, tangent of what?
A.
Yeah, capital A. We don't know what that is, right? And is it 3 over 7 or 7 over 3?
3 over 6.
3 over 7. Opposite over adjacent. Okay,
Inverse tangent.
now I'm going to do the inverse tangent to get him to go away, right? That cancels him there. So inverse tangent of 3 over 7, and capital A is
23.2.
23.2. Okay, then what?
90 minus
Yeah, like these have to add up to be 180, right? So we can 66.8 degrees.
Yes.
There we go. We've got all of them. Biggest angle, biggest side. Smallest angle, smallest side. Looks good to me. Okay. Beautiful.
That's good.
That's a lot. Okay. That was a lot. Oh, we still have a lot of time, but that's okay. Our brains are fried, right?
We have 5 minutes.
Oh, we do? Okay. All right. Bye, Ren.